Now let's talk about random variables and discrete probability distribution. Let me explain random variable. A random variable is a function or a rule that assigns a number to each outcome of an experiment. Alternatively, the value of a random variable is a numerical event. Instead of talking about the coin flipping event as a heads or tail, think of it as a number of heads when flipping a coin. Instead of a real event, we are going to use a numerical event. Like heads or tail, 1, 2, 0. Types of random variable. Generally, we have two kinds of random variable: discrete random variable or continuous random variable. Discrete random variable is one that takes on countable number of events. It takes on countable number of events. For example, value on the roll of dice 2, 3, 4, 12. If they add 2. And continuous random variable, one whose value are not discrete, not countable. Time, weight, this one. Okay, it's called a continuous random variable. Integers are discrete, while real numbers are continuous. You can think like this. Do you understand what is a random variable, discrete random variable, and continuous random variable? You should understand. Probability distribution is a table, formula, or graph that describes the value of random variable and probability associated with this value. That's what probability distribution. So you should understand what's the definition of a probability, random variable, and probability distribution. It's a table or formula or graph that describes the value of a random variable and probability with this value. Since we are describing random variable which can be discrete or continuous, since we are describing random variable, we have two types of probability distribution: discrete probability distribution, then continuous probability distribution. Probability notation. Uppercase letter will represent the name of random variable, usually large X. Usually large X. Its lowercase counterpart will represent the value of random variable. The probability that random variable will equals X using this. So if it is a value, we use a small case letter X. So probability X equal X, more simply, we just use this. So large X means what? Random variable, name of a random variable. The probabilities of the values of a discrete random variable may be derived by means of probability tools such as a tree diagram or by applying one of the definition of probability, so long as these two conditions applies. Probability is between 0 to 1 for all x, and for all x, summation probability x is equal to 1. If these two conditions are applied, is satisfied, then we can say x is a random variable, and then probability x is defined. Let's see example. The statistical abstract of the United States is published annually. It contains a wide variety of information based on the census as well as other sources. The objective is to provide information about a variety of different aspects of lives of the country resident. One of the questions asks household to report the number of persons living in a household. the following table summarizes the data to develop the probability distribution of the random variable defined as the number of person per household. So here, random variable is the number of person per household. Then the first column, number of person, is going to be what? Random variable. And then using this and using kind of relative frequency approach, you can define the probability. Can you have idea? Then probability distribution can be estimated from relative frequency. So probability x equal 1 is 31.1 divided 116. In the same way, you can estimate other probability. If you add this all probability, then it should be equal to 1. Right? Then you can have a question like this. What is the probability that there are 4 or more persons in any given household? 4 or more. Right? You have to add this all probability. So probability x is greater than or equal to 4 is a probability 4 plus probability 5, 6, 7 or more. Then the answer is 0.237. It's easy, right? Let's see another example. A mutual fund salesperson has arranged to call on 3 people tomorrow. Based on past experience, the salesperson knows that there is a 20% chance of closing a sale successful on each call. To determine the probability distribution of the number of sales that salesperson will make. So this is a number of sales the salesperson will make is a random variable x. Then we want to construct the probability distribution. Here we are going to write let S is a random variable. And then closing a sale is 0.2, not closing a sale is 0.8. Success means closing a sale. Do you understand? Then we can develop a probability distribution. So this is random variable x. This is a probability distribution. Then x equals 3, x equals 2, x equals 1, x equals 0. So this case is x equals 3. This red case is a probability x equals 2. Okay, x equals 0 is this case. Okay. Then we construct the probability distribution here. Discrete probability distribution represents of population. Do you know what is a population? What is a sample, right? Example 7.1, population number of TVs per household. Example 7.2, population of sales called outcome. Since we have a population, we can describe them by computing various parameters. For example, the population mean, population variance. We know, we learn without defining random variable, we calculate mean variance. But now we introduce random variable, and now with the random variable, we are going to define mean and variance. Population mean, or we call it expected value. The population mean is a weighted average over all of its value. The weights are the probability. This parameter, we call it parameter. This parameter is also called the expected value of x, is represented by expected x. So expected x is equal to mu is equal to for all x summation x times px. And this is called what? Population mean. You should know and understand. Then now we define population variance. The population variance is calculated simply, similarly, it is the weighted average of scaled deviation from the mean. So variance sigma square is equal to for all x summation x minus mu squared. So that's what scaled deviation from mean times probability x. This is a variance. As before, there is a circle formulation. So without calculator, without calculate x minus mu square, we can calculate the variance using this. So if you express this above formula, then you can get this one. Summation x square times px minus mu square. So standard deviation is the same as before. Positive square root is called what? Standard deviation. So you have to, with the random variable, you should know how to define mean and variance and standard deviation. Let's see example. Find the mean, variance, standard deviation of the population over number of person per household. From example 7.1. In 7.1, we define the random variable and the probability. Using random variable and probability, we can calculate mean, right? And variance and standard deviation. So first, the mean is from the definition, expectation x is summation what? X times probability x, right? So calculate this. 1 times probability 1, 2 times probability 2, like that. Then probability 1 is 0.268 and probability 2 is 0.333. So up to 7. 7 more is 7. Okay. Then we can calculate the mean is 2.513. 2.513. The next part is variance. Because we already calculate the mean, now variance. Variance is 1 minus mean square times 0.268, 2 minus mean squared times 333. Then we have a variance 1.958. Then standard deviation is a positive square root. So it is 1.399. Don't just look at what I did. You just calculate, right? You should know how to calculate. Why you should know calculate it? To understand that. And then see what's the meaning of that. What's the meaning? That's important thing. Now we are going to learn rules of expected value. Using definition of expected value, we can derive this rule. Expected value of constant is expected value of constant is just the value of a constant. Expected value of random variable plus constant is expected value of random variable plus constant. Expected value of constant times x is equal to constant times expected value of x. So we can pull a constant out of the expected value expression, either as a part of a sum with the random variable x or as a coefficient of random variable x. If you are good at mathematics, this can be derived from your mathematics. So if you can, then do that. But if you don't know, then just try to memorize this. Let's see example. Monthly sales have a mean over $25,000 and standard deviation mean over $25,000. Mean over $25,000. Standard deviation $4,000. Profits are calculated by multiplying sales by 30% and subtracting fixed cost $6,000. Find the mean monthly profit. First, we will find the mean monthly profit. Can you do that? Let's try. Try to find expected X. How do we get from this? Describe the problem statement in algebraic term. First, algebraic term. Sales have a mean over $25,000. So expected sales is $25,000, right? And then profit are calculated by profit is 0.3 times expected 0.3 times sales minus 6,000. Alright. Then expected profit is equal to expected 0.3 sales minus 6,000. Here, what is random variable? Sales is random variable. And you can see this is all random variable. What sales is random variable. And this is what? Constant. This is a constant. Oh, you can use rows over expected value. Rows over expected value. Then, by rule number 2, by rule number 3, then add the previous expected sales. Then the answer is mean monthly profit is $1,500. Not very difficult, right? So expectation AX plus B. Here X is a random variable, AB is a constant, then it is equal to what? A times expected value over random variable X plus B. Okay. Now we will see rows of variance. Variance of constant is 0. So variance of constant is 0. And variance over random variable X plus constant is equal to variance over random variable. The variance of random variable and the constant is just the variance of the random variable. And variance over constant times random variable is a constant squared times variance X. So variance of random variable and constant coefficient is the coefficient squared times the variance of a random variable. So look at this problem and then how to find the standard deviation and before standard deviation variance. So variance and standard deviation. Try to solve this one. I'm going to give you some time, so try to solve. Describe the problem statement in algebraic form. So sales have a standard deviation over $4,000. Probability sales $4,000 scaled. So $16,000. Remember the relationship between standard deviation and variance. So profits are calculated by profit is 0.3 sales minus $6,000. Using this, Last time using this, we calculate expected profit. Now we are going to use variance of profit. Then the variance of profit is a variance profit. See how to calculate variance of profit. Then using rules of variance by rule number 2. Okay. By rule number 3. Then we get the variance. Again, standard deviation is the square root of variance. So standard deviation of profit is $1,200. Okay, you know how to calculate, right? Check your answer is right. So summary, mean monthly profit is $1,500, standard deviation $1,200. Now let's move to a little bit more difficult part. Up to now we have looked at a univariate distribution, that is a probability distribution in one variable. You might guess bivariate distributions are probability of a combination of two variables. Bivariate distribution. Bivariate probability distribution are also called joint probability. Joint probability distribution of x and y is a table or formula that lists the joint probability for all pairs of value x and y, and is denoted by probability x and y is equal to probability x and y. Then just like univariate distribution, this is a condition of probability x and y. Condition of probability x and y, first condition is between 0 to 1. For all x and y, summation x and y is equal to 1. So as you might expect, the requirement of bivariate distribution are similar to univariate distribution with the only minor change to the notation. Now let's see example 7.5. Xavier and Yvette are real estate agents. When X denotes number of households Xavier will sell in a month. So X is a random variable. What is a random variable? X, meaning number of houses Xavier will sell in a month. Now let's define random variable y. Random variable y is a number of houses Yvette will sell in a month. So we have two random variables. An analysis of the past monthly performance has the following joint probability. Then we can construct this joint probability distribution, and this is a marginal distribution for y, and this is a marginal distribution for x. So as before, we can calculate the marginal probability by summing across row down column to determine the probability of x and y individually. So this table is for probability of y, and this is for probability x. Okay, probability of Xavier will sell one house is equal to 0.5. So you can construct a marginal probability with this from the joint probability table, right? Then we can describe mean, variance, and standard deviation of each variable in a bivariate distribution by working with a marginal probability. By using marginal probability, we can calculate the probability x, and then expectation x, variance x, standard deviation, and then we can calculate expectation y, variance y, sigma y. You should do it by yourself, right? You should know how to calculate expectation Y, variance Y, standard deviation Y. Don't just using your eyes. Use your hand and then try to calculate this. If you do not do that, if you don't do that, then you cannot understand. Please play with your hands. It's very important. Then covariance of two discrete variables is defined as using this formula, or this one is a shortcut formula. Whatever for your convenience, use easier one. Covariance xy definition. Covariance xy is for all x and for all y, summation x minus mu x times y minus mu y times the joint probability, probability x and y. So using this formula, using this formula, you can calculate the covariance. After covariance calculation, you can calculate what? Coefficient of correlation. Correlation coefficient. Then the coefficient of correlation is calculated in the same way as described earlier. So rho is covariance xy divided by sigma x, sigma y. Sigma x is a standard deviation for x, sigma y is standard deviation for y. Compute the covariance and coefficient of correlation between number of households by Kasebian and Yvette. Covariance, this is definition of covariance. Using this, you can calculate covariance. So this is x equals 0, x equals 0, x is changed, x equals 1, y. So y, mu x, mu y, 1 is x, mu x, y, mu y, probability x equals 0, y equals 0 is 0.12. Probability x equals 1, y equals 0 is 0.42, like that. And this, then you can calculate the new answer is covariance is minus 0.15. And then you can calculate correlation, coefficient of correlation is equal to using sigma x, sigma y. Then correlation is minus 0.35. So there is a weak negative relationship between the two variables. So using covariance and coefficient, you can calculate covariance and coefficient of correlation and see the relationship between two variables from the data. So this is x and mu x, this is y, mu y, and probability of a combination, then x minus mu x, y minus mu y, then this is we calculate coefficient of correlation, as you can see. Then let's see sum of two variables. The bivariate distribution allows us to develop the probability distribution of any combination of two variables. Of particular interest is the sum of two variables. So now we want to construct the distribution of a sum of two variables. Sum of two variables. If we consider our example of Kasebian and Yvette selling house, we can create probability distribution x plus y. So this is a probability x plus y, distribution of x plus y. To answer question like what is the probability that 2 households sold? Then you can calculate. Can you calculate it? 2 households. What is the probability that 2 houses are sold? Is equal to probability x equals 0, y equal 2, x equal 1, y equal 1, x equal 2, y equal 0. So you can get probability x plus y equal 2 is calculate like this, and then the answer is 0.19. Likewise, we can compute the expected value, variance, and standard deviation x plus y in the usual way. So expectation x plus y, use your hand, then try to calculate, and it is right, check it is right or wrong. You can get 1.2, variance x plus y, check it. It takes time. It's 0.56. And then sigma is a positive square root, then 0.75. You can use a calculator too, okay? For univariate variable, we use rows of expected value, rows of variance. Likewise, we can derive rows of expected value, variance for the sum of 2 variables as follows. Expectation x plus y is equal to expectation x plus expectation y. Variance x plus y is equal to variance x plus variance y times plus 2 times covariance x plus y. If x plus y are independent, covariance is equal to 0, and then variance x plus y is equal to variance x plus variance y. You see, variance x plus y is not just variance x plus variance y. It is plus 2 times covariance xy. Check. Then in our example, expectation x plus y is 1.2, variance x plus y 0.56. Check if this calculation is right or wrong. You can use your hand. Is it right? Then we are moving to special distribution, binomial distribution. The binomial distribution is the probability distribution that results from doing a binomial experiment. Binomial experiments have the following property. First, the fixed number of trials represented as n. Second, each trial has 2 possible outcomes, a success and a failure. Probability success is P, and thus probability failure is 1 minus P for all trials. The trials are independent, which means the outcome of a trial does not affect the outcome of any other trial. So we have 4 properties here. So it is a binomial property. Okay? So random experiment, these binomial properties, then you can use binomial distribution with the binomial random variable. So try to understand these 4 properties. In binomial properties, success and failure are just labels for binomial experiment. There is no value judgment implied. For example, a coin flip will result in either heads or tails. If we define heads as a success, then necessarily tail is considered a failure. In as much as we attempting to have the coin lands head up, other binomial experiment notion, election candidate win or lose. You can use success and failure. Employee is a male and female. You can use a success and failure. The random variable of a binomial experiment is defined as the number of success in n trial and is called the binomial random variable. Random variable of a binomial experiment defined as the number of success in n trial. This is a kind of meaning of a random variable x for binomial random variable. X is defined as the number of success in n trial. Is called the binomial random variable. For example, C, flip a fair coin 10 times. Fix the number of trial n equal 10. Each trial has two possible outcomes, probability of success, head, tail, failure, and probability success is 0.5. Probability failure 1 minus 0.5. The trials are independent. That is, the outcome of head on first flip will have no impact on subsequent coin flip. Hence, flipping a coin 10 times is a binomial experiment since all conditions were met. The binomial random variable counts the number of success in n trial of a binomial experiment. It can take value from 0, 1, 2, and thus its discrete random variable. To calculate the probability associated with each value, we use combinatorics. So then this is a probability distribution of a binomial random variable. Probability x is a n combination x. This part is a n combination x. So n factorial divided by x factorial n minus x factorial. This is a combination, n combination x. P to the x, p is the probability of success to the x, n minus p and minus x for x equals 0 to n. Let's see this example and calculate the probability distribution using previous probability density function, probability distribution function. Pat's tested is a student, not good student, joking, is a student taking statistics course. Pat's exam strategy is to rely on luck for the next case. The quiz consists of 10 multiple choice questions. Imagine that 10 multiple choice questions. Each question has 5 possible answers, only one of which is correct. Pat plans to guess answer to each question. What is the probability that Pat gets no answer correct? What is the probability that Pat gets 2 answers correct? Try to solve this, compare with my solution. Try to get answer. I'm going to give you time to also try to get answer. Okay, let's see how to approach. As likely n equal 10, so probability success is 0.2. Agree? Then see, it is a binomial experiment or not. Check condition. There is a fixed number of trial n equal 10. Answer can be either correct or incorrect. Probability of correct answer success is 0.2. Does not change from question to question. Each answer is independent of others. So what? It is a binomial experiment. Do you agree? Then what is the probability Pat gets no answer correct? That is success number of success x equals 0. Hence you want to know probability x equals 0. So probability x equals 0 is equal to 10 factorial divided 0 factorial 10 minus 0 factorial 0.2 to the 0, 1 minus 0.2 to the 10 minus 0, then we get 0.1074. So Pat has about 11% chance of getting no answer correct using guessing strategy. What is the probability Pat gets 2 answers correct? Then just using x equal 2. Put just x equal 2 to the probability distribution formula. Then probability x equal 2, then you get 0.3. So Pat has about 30% chance of getting exactly 2 answers correct using the guessing strategy. Is this answer is the same as you? Can you check it? Thus far, we have been using binomial probability distribution to find the probability of individual value of x. To answer the question, find probability that finds the keys requires a cumulative probability. That is probability x is less than or equal to x. If grade on keys is less than 50%, 5 questions out of 10, that's considered the failed case. Thus, you want to know what is the probability x less than or equal to 4 to answer. Okay. And we can calculate the probability x less than or equal to 4. Then probability x0, 1, 2, 3, 4. We already know probability 0, probability 2. Using binomial formula to calculate the other probability x equal 1, probability x equal 3, probability x equal 4. So we have x equal less than 0 or less than 4, less than or equal to 4 is equal to 9672. Thus, it's about 97% probability or probable that Pat will fail the test using log strategy and guessing at the answer. In your textbook, you can use a binomial table. Calculating binomial probability by hand is tedious, especially for cumulative distribution. So there is an easier way. Refer to table 1 in Appendix B for the past test example n equal 10. So the first important step is to get the correct table. So find the n equal 10 here. N equal 10. Then the probability listed in the tables are cumulative. As I told you, it's cumulative. So probability x is less than or equal to k. And here, what is the meaning of k? K is the row index, and the column of tables are organized by probability success p. So this point 2 is a probability success. So in our question, what is the probability that Pat gets no answer correct? Then probability x equals 0, probability success is 0.2, n equals 10, so you have to find the table n equals 10, and then x equals 0, so k equals 0, and then success is 0.2, then the your answer is here. Probability x equals 0, because it is a cumulative probability x is less than or equal to 0, but this is the same, so you get the 0.1074. How about what is the probability that Pat gets 2 answers correct? What is the probability that Pat gets 2 answers correct? How do you get the answer? You have to use this one. Probability x equal 2 is equal to probability x less than or equal to 2 minus probability x less than or equal to 1. So using this 2. Okay, 0.6778 minus 3758. So 3020. That's what? what is the probability that Pat gets two answers correct? Binomial table gives a cumulative probability for probability x is less than or equal to k. But as we have seen in the last example, probability x equal k, to get this answer, you can use this. Likewise, for probability given as probability x greater than k, we have this. You have to use this. Also, in Excel, you can calculate binomial distribution. There is a binomial distribution function in Excel that can also be used to calculate this probability, or other distribution too, actually. What is the probability Pat gets two answers correct? Use this parameter, probability of success, trial, success, cumulative, true or false. Okay, then you get the probability x equal 2 is 0.3. You can use Excel, and when you meet offline, I will show you how to do that. Don't worry about that if you don't know from this slide. And now you can use in Excel, and you can use cumulative too. What is the probability that prepares the keys? Okay. Then in here you have to use cumulative 2. If you have Excel, use this one, then try to get the answer. As for final part of binomial distribution, let's see what is the distribution, what is the mean and variance of binomial random variable. As you might expect, the statisticians have developed general formula for the mean, variance, standard deviation of binomial random variable. They are mean mu is MP, sigma k is MP1 minus P, standard deviation is square root MP times 1 minus P. It's mean, variance, standard deviation. Stay, let's finish this, okay? Next time we will talk about Poisson distribution. And today, we run probability rule, first the addition rule, and we run the probability tree, Bayes law, random variable, mean and variance. I introduce what is meaning of, what is definition of random variable, and mean and variance, how to calculate mean and variance, and then we run the bivariate random variable, covariance, coefficient, meaning, and how to calculate. Then I explained the laws of expected value and variance. Then we run binomial random variable, and then we learned what do you learn? We learned expectation, binomial random variable, and variance of binomial random variable, and then binomial property, experimental property we learned. Important thing, next week we may have a quiz, and you should submit your previous homework next week. I'm going to show you how to, I'm going to tell you how to submit in BB, Blackboard, and we have more homework today. Today's homework is due April 20th, and topics next week are Poisson distribution and continuous distribution. Thank you for your attention. See you next week. Bye.